Okay, today we're working on the robotic stacker design brief. There is a lot of YouTube videos out there, and we actually have some on our YouTube channel that you can take a look at. I would talk about different types of cranes, and if we scan down here, we can see the specs. The robot has to be assembled as a tower by stacking 3 blocks of different sizes. So this is really what it needs to accomplish. But if you want to have kids make it accomplish different things, that would be fine too. Maybe one that would brush your teeth or comb your hair or pick up a pencil and write. You can have some creativity here. Basically what you'll need is actually 8 syringes, and we'll need at least 4 12-inch pieces of plastic tubing. I would say between 4 and 6 feet. And you need something for a base. A dowel rod will help. But the main thing is, what you want to do is just follow the system here and make sure you take a look at the rubric. And first of all, the students should identify the problem. And with brainstorming, I would really break this crane down into 3 parts. It needs to swivel, it needs to extend and come back, and then it needs to have a device that will pick up an object. So actually the students might want to plan this in 3 different steps, because there's 3 main pieces of the arm that they're going to have, and this is really where you want to plan it out. And hopefully they generate some ideas there and use some references and take a look at what criteria and constraints they have, and brainstorming ideas. This is a difficult project, but a very good one. And we go on down through here, and then the materials that they plan on using. They want to develop a design for the highest scoring, and you want to include sketches. Make sure they have the dimensions, attach their working drawings. They could also build maybe a little piece of an arm, or for a beta test would be a good idea. I would make definitely a little prototype it could be made out of manila folder or something, how that arm is going to open, or how the crane is going to go up or move side to side. I think it's an excellent place to put in modeling and prototyping here. Now, my crane that I'm going to be building at home and will be videoing as well will actually be a hydraulic robot made of cardboard and Scotch duct tape. So I'm going to build a simple hydraulic robot, cardboard, hopefully here, and we're going to I want you to encourage your students to use different materials and have the arm do different things. I don't want you to show them this. We want creativity. We just want to show you maybe how to plan it a little bit. For my robot, this is all I'm going to need. I'm going to need a cardboard or foam board here, and the harder the better, but I use foam board, but you can use any type because we're going to reinforce it with duct tape. You could even use a pizza box. I bought some silver duct tape because I think it looks cool. You can use something here. I've seen people use machine screws. I have some dowel rods that I may use. You can need a flat piece of wood, something real thin to put it on. You actually could use cardboard. I bought mine at Michael's craft store for 8x10 for $1. You need 8 syringes, 4 to 6 feet of tubing, and definitely some tools. Scissors, roller pen, drill will help, but you could probably use a hole punch or just punch it. Just punch it with a pencil and pen. You could probably do that if you're not in a shop. Okay, once students brainstorm a little bit and take a look at these cranes, you're going to see that the next step is they're going to plan out their crane. And one of the biggest things, one of the tools I recommend, of course, is a square. And what we really want to focus in on is the students using the least amount of materials possible. For example, my base, I didn't have a drawing tool here at home, so I wanted 6 inches around. All I had was a plate. I just put it on there, sketched it in a 1/2 inch around the outside. If we can take a look at that.
and that's going to be my base. There has to be something for that arm to pivot on left and right. The next thing is, of course, I need to create something that's going to grab the can or whatever you're doing. I just sketched this out, and in here is where is going to be my pivot point. The other two parts here are going to be, this is going to be going up from the base up to the top, and I created two of these, and they're 3 inches and 2 inches, but you see how I maximized my material. What I did, I knew it was 2 by 3 here, so this one will be 2 by 3. And then this one is going to be the ones going out onto the arms, and this is going to be a support for that. So I'm going to be creating other material, but I'm going to go and cut this out. Now, why did I only draw one specific arm? Because I had to freehand that one. And what I want to do is, once I cut that out, I'll come back and trace it, and I'll make an identical one on the other side. Okay, now I have most of my pieces cut out. Now what I'm going to do is reinforce those with duct tape. Okay, now I have all my parts covered and all I have is silver duct tape. And the next thing I'm going to do is start to work on my base. And my base is going to be held up like this. So what I'm going to do is create some supports to go inside here and to actually hold these up, because I need this supported about that width apart, about 2 inches. Now, no matter what your students are doing, basically they're going to need something that's going to turn the crane. That's where this is going to come into play here. And what I'm going to do right now is I'm going to take actually some dowel rods, go across here, these two places, and just connect them. You could do it any way you want, and then I'll probably come up with some small little dowel rods here on the side just to hold this steady. And what's going to happen is this is going to be able to turn my crane this way. I'm going to put maybe a screw or a dowel rod up through there, and it's going to pivot on my major piece here. So this is going to have to pivot. You're going to need something to turn this crane from left to right to make it go back and forth, and that's what this base is going to do. Most people go with a round cylinder object, something like this. Okay, you can see what I've completed so far. I have my frame here. Every robotic arm is going to need a frame, and I just have a dowel rod coming up through the middle, and that dowel rod will go down through my platform, and it will eventually be glued on here. So one of the first pivot points you're going to have is this robotic arm is going to have to turn left to right. This is basically what I've built so far. So this, everything else in here, this is going to be attached. It's going to be glued there. The only thing that is not going to be, or it's going to be glued down here. The only thing that's, you know, this arm is actually, this peg is going to be glued, and when it's held in there, this arm is going to pivot around there. So this is actually loose here. I'm going to take a washer and sort of glue it right here so it doesn't come out. Right now I could pull this rod out. So you are going to need something right here to prevent this from coming up. I'm just going to, since this is a 1/4 inch dowel rod, I'm going to take a 1/4 inch bolt and just glue it right there on the top, just to prevent it from coming up out of there. Okay, so that's really the base of your robotic arm. Okay, the next step is we're going to be making the next part of the arm. Basically what I did is I created a 1 inch cube there, because I'm going to have a pivot point right here going through here. I had to measure the distance between the two, and all I did was put this in here, and then I'm going to tape this together, leave about 1 inch, and that's going to be right here. This box also will give me a place to tape my syringe onto. So it'll be on like that because it'll be moving in and out. So that's going to give me a holder for my syringe, and so I'm going to put these two together. Then I'm going to put a pivot placed through there, maybe a dowel rod, or you could use a just a bolt through there, or anything, pencil, straw, anything. Just give me a pivot point right there. All right, so what I've done is I drilled a hole through the outside here. I kept this a 1/4 inch, and I just made a box, square box. It gave me reinforcement, and you can see how easy that just pivots on there. The actual hole that I put through this part was a little bit bigger. Instead of a 1/4 inch, I think I went like 3/8 of an inch. And I did the same thing down here. So now I have my pivot on this arm as well. Okay, and the next thing I'm going to be making is the actual claw. So right now I've got this one completed, and the next thing I'm going to do is the claw. And I did the same thing here, just made a 1-inch cube. I like the duct tape, you don't have to glue it or anything, just tape it on there, and there's and my arm is starting to take shape here. Okay, the next thing I did is I made 2 square boxes again, put them inside there, taped my first syringe on here, and if you just test it out, if this syringe pushes up, okay, what's going to happen is my arm, I wanted to make sure it goes down to the ground. If when the syringe gets pulled back in, it will come back up. Nice thing in the duct tape too, there's a little give there, so it's not, it can move a little bit. The actual syringe is going to be moving a little bit. So once that syringe comes out, my arm will then go down to the ground, and when it gets pulled back in, it'll come off the ground. So just have a duct tape there, pretty good, and that's the first one I have. Okay, for my second pivot point, I actually used a zip tie, just put it in there, tied it on a rope, mounted my syringe nice and secure with the duct tape. I came down and then I went back with the strip, but I don't want to get any tape in there. I want to keep that one free. But you'll see when this comes back what happens to this arm right here. It's going to come up, and then when I release it, it's basically gravity. It's just going to let it go right back down. It gives me a great range of motion, almost like a 90-degree angle there, and I'm going to come up to 180, nice and flat. So I like the string in there. I just put a zip tie, put a hole, taped it, secured that, and there's my arm coming up right there. Okay, the last thing I'm going to be making, I'm going to cut about a 4-inch piece. I'm going to put it in there so I can stick it out, and this is going to be the mounting for my claw. So I'm actually going to have to mount the syringe on there for my claw. So I'm going to cut a piece. I'm going to cut that a little bit nicer. It's got to fit inside this end piece here and stick out, and then I will attach that claw somehow. I'll have to figure it out how it's going to pivot, and this is what's going to pick up the device once the robotic arm goes out there. So you can see it's really in stages. Okay, now I'm almost finished with my arm. Basically, I'm just going to put a rubber band around it right here, and then you can see I just tied a string here and here, and when the piston comes up and pulls it up, it will pull both sides of the arm out. And then the rubber band, when the piston comes back down and is released, the rubber band will be on the arms and pull it back together. And so that's how I decided to put my arm. There's multiple ways to do that. So basically, the robotic arm now is finished, and the only thing left I have to do is hook up all the tubes, and I should be ready to go. And that's basically it. Remember, you need something to pick it up, something to move it up and down here, and what I did, I went with a zip tie on here now, and then also on the back here, the piston that's going to lift it up and down. So that's it. Okay, the last thing I did was just hook this up right here, and you can see when the syringe is in, it turns. When it pushes out, it rotates back. And I was able to put the rubber band on here, so you will pull it back, it opens up. When you slide it down, it closes out. And that's it.